I don't know if that sound is okay. So the objective of my work is to determine the phenotypic and nutritional difference So the ones that I selected were 10. Some have been released to seed companies, that is Madeira 1 and Madeira 2. I hear they have been released, while some are still breeding lines. So the 10 amaranth lines were first sown in trays in a greenhouse, and then later transplanted into the phenospecs field or in field under normal field conditions. That is 2 weeks after planting. Then for a period of 3 weeks as the plants were growing in the field, morphological characterization was done using an equipment which I'll explain in the next slide. This was done for 3 weeks. So after 3 weeks, in a total of 5 weeks, the plants were harvested, the leaves separated, and a nutritional analysis done for the leaves. After that, of course, data analysis was done on the morphological characteristics as well as the nutritional characteristics. So the morphological characteristics that were analyzed include digital biomass, average greenness of the leaves, average plant height, average hue of the leaves, and the 3D leaf area. The 3D leaf area is basically the total area that is covered by the leaves, as can be seen by the phenospecs. So the characterization was done using phenospecs equipment. Phenospecs is pictured here. I did this experiment at World Vegetable Center in Taiwan. So this is PhenoSpecs. It is an equipment that is fitted with two pairs of cameras. This is one pair, this is another pair. So this is just a zooming of one pair of cameras. So it moves, it is a 3D phenotyping technology. It moves on top of the plant canopy, taking several measurements of the morphological characteristics. Apart from the cameras, it also has environmental monitoring system and a software where data can be analyzed and downloaded. So from this, it generated 3D cloud of the crop canopy from which morphological traits were extracted. So this PhenoSpecs equipment can take several measurements in a day, but for this particular experiment, it was set to take 3 measurements in a day. So after the morphological characterization, I did the nutritional analysis, which was done 3 weeks after transplanting, a total of 5 weeks since the crops were sown. And the nutritional components that were analyzed includes oxalates, carotenoids, vitamin C, minerals, and flavonoids. These were done according to laboratory protocols that are listed there. Sorry. Next. Just go back. Yeah. Yeah, next one. Next. No. Next. Okay. So that is basically my method. So I go to the results. The results of the morphological characterization are in 2 parts. There is the daily changes that were being recorded by the PhenoSpecs, the changes in the biomass, the changes in greenness, height, hue, and the leaf area. So all the values for the daily changes were positive, indicating that there was an increasing trend. This is an average of all the values that were recorded over the period of 3 weeks that the plants were growing in the field. So the digital biomass represents the total biomass of the plant, of all the plants that were in one block. That is why you see high values. The greenness is the average, height is average, hue is average, while leaf area is also a representation of the total leaf area of all the plants in the block. So here there were significant differences between the varieties, but as we can see, there is AM1902, which is an amaranth called RUAM 1903 and 1904. They were not significantly different in the daily changes of the morphological characteristics. And this could mean that they were growing at more or less similar rates. Their rates were not so different. Some were growing faster, like the AM 1908, that is Amaranthus tricolor, and AM 1907, called Madira 2, they had higher increase in the biomass. So the second part of the morphological traits were now the morphological traits as taken on the day of harvest. And this was still now the total digital biomass, not the daily increase, but the total digital biomass, the greenness of the leaves, and the height, the hue, and the leaf area. These were taken at 5 weeks of growth. And these are, the values represent means. The values with different superscripts show that they're significantly different. So there were significant differences among them all. There's this variety 9. If you remember where I showed the different types of the plants, variety 9 is Amaranthus blitum. And for those who know Amaranthus blitum, it is a small variety. It has small leaves. It does not branch so much. It does not grow so big. So it had significantly lower characteristics compared to the other 9 varieties that are here. Next, please. It's okay. So for the nutritional attributes, the nutritional composition, there is this oxalate. Oxalate is an anti-nutrient that is found in vegetable amaranth. The levels that are in vegetable amaranth are not so much that they can kill you or harm you directly, but what they can do is that they can bind iron and therefore prevent your body from getting the iron which might be in the plant or in any other food. So that is the most serious effect of oxalates. There are carotenoids that were analyzed by HPLC, and 5 types of carotenoids were found to be in the vegetables. And then vitamin C, all this data is on fresh weight basis. The amounts were considerably high compared to other vegetables, and this is a good sign. So if you look at them, there is no particular trend for example, a species. We cannot say that hypochondriacus species, because hypochondriacus are 1 to 4. So we cannot say that hypochondriacus had a particular trend, or the cruentus had a particular trend. There was no particular trend, but notably Amaranthus tricolor, that is number 8 here. Amaranthus tricolor showed quite high values. The values that are highlighted in blue are the highest for each component, while those highlighted in red are the lowest for each component. So Amaranthus tricolor showed quite high in most characteristics. Unfortunately, it's also high in oxalate, which is an anti-nutrient. So the others, there were no significant trend. For calcium, iron, and zinc, still the Amaranthus tricolor was leading in all of them, while this Amaranthus blitum was significantly lower in 3 types of flavonoids, 3 types of flavonoids out of 4. So in all the other parameters, there is no particular trend still. So after that analysis, I went ahead and did a correlation analysis between the morphological characteristics and the nutritional characteristics. And in most of them, as you can see from that table, the ones highlighted in blue and with asterisks show that there was significant difference. And here we can only see significant correlations, not difference, sorry, significant correlation between greenness and vitamin C, and also significant correlation between hue of the leaves with 3 types of carotenoids, that is xanthine, neoxanthine, and lutein, as well as zinc. All the others showed low correlations that were not significant. So in my conclusion, I conclude that there was significant difference in both nutritional and morphological characteristics of the 10 lines that were evaluated here. Line number 8, that was Amaranthus tricolor, and line number 10, Amaranthus dubius. They're actually similar in physical characteristics, except that the line number 8, Amaranthus tricolor, has some slight purple coloration. They were highest in most of the nutrients that were analyzed. Amaranthus blitum showed lowest in most of the morphological characteristics compared to the other lines. And we also found that greenness was positively correlated. Greenness was positively correlated with oxalate and vitamin C levels, while the hue of the leaves was positively correlated with carotenoids. So from this study, maybe a message to the breeders who are maybe looking forward to breeding for nutrition. I present to you the trait of leaf color. Leaf color can be targeted as a trait for breeding for nutrition because it's the only one that showed significant correlations with some of the nutrients. So thank you very much. Acknowledgement go to BMZ and GIZ for funding the project through Amazing Amaranth, which gave me the scholarship to do this work. Also the World Vegetable Center Nutritional Unit and Biotechnology Unit where this work was conducted. I would also like to thank JQuat for giving me the opportunity. I also like to thank the TAV conference organizers for sponsoring my being here today. So thank you very much for listening.
I'll give her a hand. Before you go, and we go, which variety of amaranth has the highest, the highest digital biomass? And does it make business sense now for us to go for that? Because I know farmers want to know which variety will give me more biomass. Because I don't want to plant 1 acre and I get 1 ton. But as a variety, I can have the same acreage and get 3 tons. Which one has the highest digital biomass? Also, the best nutritional value.
Okay. There is this variety called Amaranthus tricolor. It is a new breeding line. The breeder is here, so I am speaking for him. There is also Madeira 2. Madeira 2 has actually been reported to be a high-yielding variety. It's also a new variety, though of the grain type. So in some parts of the country, you will find that people will not like its leaves very much. But Amaranthus tricolor, it is called UGM 23. Maybe Dr. Fekadu will give you a better name. UGM 23 had the highest biomass, so it's high yielding, and it also had the highest nutritional traits. Yes.